All right. Can everybody hear me? Hello, hello. Hey folks, so we're going to start the first industry session. My name is Joaquin and I work at Facebook. I manage the ads optimization team as well as the machine learning platform that everybody uses. So I'm pretty excited to introduce the first of our 3 industry sessions. I think Anmol mentioned yesterday that the way this is going to work is as follows. Today, in this session, we're going to be hearing about applications of personalization and recommender systems in sort of what you could call large companies and well-established applications. The next industry session will be interesting because we'll be talking more about stuff that's out there, that's a lot crazier and tentative. And then finally, I'm pretty sure that you're quite sensitive to the many controversies that arise around personalization. So we'll have a panel as a third industry session where there'll be sort of a heated debate. At least we're hoping there'll be a heated debate. So today, we're going to hear 4 talks right now. The first one is going to be about the basics, experimentation, right? If you can't A/B test, then we're done. After that, there'll be 2 talks from Facebook. One of them will be on how do we recommend to Facebook users the right Facebook pages to look at. The other one will be, if you think of your newsfeed as your own personalized newspaper, how do you generate over 1 billion personalized newspapers? And then finally, we'll have a talk from Criteo on how to personalize display ads in display advertising. So it's my pleasure to introduce Ya, who's going to talk about experimentation.
Thank you. Good afternoon. My name is Ya, and I lead the A/B team at LinkedIn. We're now going to switch gear a little bit from deep learning to talk about A/B testing. In particular, I'd like to talk about the challenges that we at LinkedIn actually have seen as we try to scale our experimentation. So the concept of A/B testing at a very high level is simple. I have a yellow button on the page that I don't think it's getting enough clicks. So how about a green button instead? To do it in the A/B testing way, I'm going to start to randomly sample users to see the green button. And then at the end of the day, I will compare and I will collect data from both buckets of users and actually compare them side by side to decide which one is actually better. The old version, the yellow button, is my control. And the new version, the green button, is my treatment. So it may be surprising, but it turns out that one of the biggest challenges is actually really decide what we should be A/B testing on. Let me start with a story. So on LinkedIn, for each of our members, we have a profile page. So on top of the profile page, we actually have a line of text, and that is our top ads. So whenever somebody clicks on these ads, we make money. Towards the end of last year, we saw a sharp drop on the click-through rate on these top ads. There was over 30% drop. So what do you think happened? The team spent days trying to figure out what went wrong. Was it because of holiday effect? It was indeed close to Thanksgiving. Not really. Was it because that we launched a new feature that just wasn't performing as well as we thought it was going to be? No. It turns out that it was because during a bug fix, 5 pixels were accidentally removed between the navigation bar and the top ads. And that 5 pixels not only cost us a lot of resources to investigate, but also LinkedIn a lot of money because we were losing clicks on these ads for quite a few days. So when it comes to think about what we should be A/B testing on, people are very used to the idea of let's use A/B tests to evaluate new ideas. I have a new UI change, I have a new recommender system. But how about platform changes? How about code refactoring? How about bug fixes? I was always told I am usually told that this new component for the platform is just so much better. It's more efficient, it uses less memory, it's written in better code. And it also has satisfied all the exit criteria. We are ready to launch. But in a truly data-driven culture, the final exit criteria should always be an A/B test. So we have been telling folks at LinkedIn that they really should be test everything. So, of course, if we tell people that they should be testing everything, we need to have an infrastructure that is actually able to scale, to run experimentation at scale. So the basic infrastructure that's used to achieve that turns out to be quite similar across different companies. So what I'm going to do today here is I'm going to give how we actually address those challenges at LinkedIn and leave the general instrumentation infrastructure details to a couple of references at the end of the talk. So over the past year, we really have increased the number of experiments that have run through our system by quite a lot. So today, on a daily basis, we run over 200 experiments in parallel. And for each experiment, we actually process over 800 metrics and also billions of experiment events. So it turns out that most of these challenges that we have seen as we scale our experiments are actually rooted from the fact that our products are very diverse, and also our experiments that teams need to run are also diverse. We have many different pages on LinkedIn.com that we try to optimize to provide better user experience. The teams need to run online experiments and also offline email experiments. We need to optimize for members and also non-members. As Neil Hung was talking about yesterday at his keynote, that at Netflix, the users are very different. Similarly, at LinkedIn, we also have very different user segments as well, and that we need to optimize for them differently. So the way that we address this challenge is by building a centralized experimentation platform that we call XLNT. It's self-served, meaning that we can easily onboard an experiment to the system with little to no cost. At the same time, it's also customized to fit the needs of various different teams. This is essentially like we make a pizza, but the teams actually get to put on their own toppings. So what I'm going to do next is I'm actually going to go through how we achieve that in the 3 components of our A/B system. First of all, during the experimental design phase, the experiment management system actually allows teams to do a fully customized targeting. To be more concrete, for example, if I think that I actually wanted to try a larger profile picture on the profiles that are shorter with only 1 or 2 positions, I can do that easily by selecting one of the 40+ built-in targeting attributes in a dropdown. To make it even better, we can actually essentially target on only parameters that gets passed through in a request. At the same time, our online infrastructure not only is able to deploy these changes to this targeted population, but is also able to identify the users who actually was affected by the experiment. To give you an example, we have over 300 million members at LinkedIn, and I'm targeting only members with 1 or 2 positions, and that is only a small subset of the total user population. But not every single member of this target population is actually going to see my experiment, right? Only those who actually had at least 1 profile view was going to be affected, and that is my triggered population. So our infrastructure actually allows us to identify this triggered population by logging when a request is actually affected by the experiment. It also does counterfactual logging, meaning that we log even if a user is in control, but if this user would have been impacted by the experiment if he was in treatment. This is actually extremely powerful because it actually allows us to do triggered analysis, which essentially is analysis by focusing only on this green population. This is the most effective way to actually identify the signal and remove the noise that comes along with those people who were never actually affected by your experiment. So there's no point of running an experiment unless you actually analyze it. So we also built an automated analytics system. As I mentioned earlier, we have over 800 metrics that we compute for each experiment. That's a lot of metrics. So how do we manage that? The way that we do that is actually by having a decentralized ownership, meaning different teams, different product teams, actually own the logic of the metrics. But the central platform provides an easy way for them to onboard these metrics into the system. And the central experimentation team is responsible to make sure that the metrics that they added into the system are valid and also verified. Of course, we also make sure that the generation of this metric actually goes smoothly on a daily basis. As a must, we also provide p-values, confidence intervals, to help teams to actually identify the metrics that are actually moved from the ones that were just noise. We also allow the teams to actually deep dive into these metrics by slicing and dicing on segments that are fully customized by their team. Last but not least, we also have automated monitoring and alerting in place so that if there is any data quality issue, that we can be alerted right away. So, as we are running more and more experiments, one thing that we started to realize is that it's not just enough to provide the capacity for teams to run more experiments. It's also crucial to actually have tools and processes in place to ensure that the teams are actually running the right experiments and also drawing the right conclusions from these experiments. Let me start with another story. So if you have used the search functionality at LinkedIn, which I'm confident that everybody here has done so, you probably have noticed that about a year and a half ago, we have made a big change to our search. Before that, you have to tell the search box whether you're searching for a person, a company, or a job. But now the search box is actually smart enough to figure out which category you actually intended for. So that was the key feature for the what's called unified search. But that wasn't the only thing that the unified search project actually changed. As I'm showing you here in the screenshot, pretty much every single component on the landing page was also changed, from the left rail to the right rail, from the snippets to the top global header. So when the team first started to run experiments, this is what they did. They lumped pretty much every single thing together. Guess what happened? Pretty much every single metric tanked. And in order to figure out what went wrong, the team actually had to put one feature back at a time to be parity with what it was in the pre-unified search. And after a lengthy time period, they finally figured out that this unified search is actually great. It's great for the user, very positive experience. It was some of these minor UI changes that they were doing that was actually degrading the metrics. So we realized that the platform needs to actually allow to run multiple factors independently and multivariate tests if necessary, so that teams, when they run experiments, they can tease out the impact from various different factors and really be able to measure one change at a time. Okay, so who has played the game Spot the Difference? Raise your hand if you have. Not that many people. Okay, but maybe the audience is too busy in general. So, so if we have played the Spot the Difference, okay, and then we can play one all together here. So if these are the two pictures that I'm showing you, Can you tell me the differences? It's very difficult, right? With such a low resolution. How about now? Now with a slight better resolution, I can start to actually identify the bigger differences, right? I can see that one frog is having a belly button, and the lily pads are also facing in different directions. How about now? Now we can see, now we can even tell the minor differences. I can see that one frog is smoking, and the other frog is having his tongue sticking out. So this is exactly what we're doing when doing A/B testing, right? We try to tell the difference between A and B. And the better the resolution that we have, the better that we can do at detecting the differences. So let me put it in a more A/B testing example. So we all know that site speed matters. As a matter of fact, various different companies in this industry have actually done independent A/B tests to show that whenever you increase the page load time, you actually drop the user engagement. But when AC.com was doing a similar experiment, they degraded their page by 200 milliseconds, and their conclusion is that it did not matter. Is it really because AC.com users are just not sensitive to speed? I don't think so. I think it's because they did not have enough resolution, or in the statistical term, power, to actually identify the difference that 200 milliseconds actually brought. So imagine that we're running more and more experiments, right? And then a lot of them are actually at low resolution. We are really in danger of making a lot of wrong decisions, launching wrong products, and missing out on the good ones. So at LinkedIn, by realizing that, we are building tools that can not only tell experiment owners that they did not have enough power to actually to make their decision, but also try to guide them in terms of what the recommended action should be, whether they should be launching it, whether they should be ramping it up to a higher percentage, or they should actually be using be running the experiment for a longer time period. One question that I get asked a lot from our folks are really, I have this experiment that was running, but this metric pop up as significant and it has nothing to do with my experiment. What went wrong? So if you know about A/B testing, you'll be like, okay, that is pretty normal, right? Because even if I'm showing a screenshot of an AA test, we still see metrics that are significant. So it's because we use a p-value 0.05 as a cutoff, and that allows 5% false positives. So in order to address that problem, right, what we have been telling teams are really try to use a tiered significance level. What I mean by that is the metric owners should really take all these 800 metrics and divide them up into 3 different groups, right? The first order metrics are the ones that are directly impacted by the experiment. And the second order are the ones that could be impacted by the experiment. For example, if you are changing the color of the button, then the CTR of that button should actually be in the first order metric. And then instead of using a uniform 0.05 as the p-value cutoff, we tell teams to use something that's more stringent for the second order and the third order metrics. And it turns out that this actually has a very nice Bayesian interpretation. So if I consider that my null hypothesis, which is that the experiment doesn't impact the metric, is equally likely as my alternative hypothesis when I'm using a p-value cutoff of 0.05. Then by using a p-value of 0.001, I'm essentially saying that I believe that the probability that my experiment is impacting this metric is only about 2%. So by incorporating the domain knowledge, we can really help solving this multiple testing concern that we have with having 800 metrics at the same time. So one other thing that I have to say is that so far, we have mostly been focusing on talking about how we can enable people to run experiment, analyze the experiment. And when they finish running the experiments, we try to give them as many metrics to look at as possible, right? But one thing we didn't realize is that these experiment owners actually also play a slightly different role. They are also owners of the metrics. For example, if I'm on the profile team, on one hand, I'll be running experiments, try to actually optimize the total number of profile views. But at the same time, I actually also am responsible for the global health of the profile views as well, which actually is going to be impacted not just by my experiment, but also several other experiments that are running as well. So in order to provide that visibility to the matrix owners, and also make sure that the experiment owners actually, when they ramp up, they actually ramp up responsibly. What we do is we provide a tool where people can go in and then select a metric, and it gives you the top experiments that actually are impacting that metric. It turns out to be not so easy of a task, right? As I mentioned earlier, we have over 200 experiments running in parallel. So we need to first definitely control the false discovery rate. This is also a multi-objective ranking problem, because we not only should consider the impact of the experiment, but also the noise level, the duration, for example. We don't want it to be examining this experiment when it's actually having a novelty effect. How about seasonalities as well, right? So there's a lot of factors that we actually have to consider when we are doing this. So due to the interest of time, I'm actually not going to go through. There are several other challenges that we actually face because we are a member-based social network. But you're more than welcome to chat with me offline. And as I promised, I also have a list of references if folks wanted to learn more about the online infrastructure for A/B testing. Do we have time for questions?
Yeah, I've got one or two questions.
Thank you.
Go ahead. I don't know if there's microphones for
There's no.
Thanks for the talk. You mentioned that for some of the tests you look at, multiple variations of what you could have done with that button, etc., could sort of affect the outcome. And what I'm wondering is whether you're looking at the interaction effects between the 200 experiments you might be running at the same time.
That's a great question. Do we look at interaction effect? We actually, we don't look at them automatically at this point because the teams can actually run their experiments disjointly if they wanted to. So we don't do that proactively by checking all the pairwise interactions. And also from sort of a lot of studies that other kind of the research community have done, that the interaction usually happens very unlikely. But it's definitely something that we have it on our roadmap to actually be able to see, do we need to do this on a more automatic basis?
Well, I think we're going to move on in the interest of time, because otherwise we will completely consume the break. So we'll try to consume only part of the break. So thanks again.